Welcome. Just a few short words. An executive fellow of Sumitomo Mitsui Construction and also a senior principal researcher of the University of Tokyo. Kasuga has designed and built over 200 bridges. I don't know who has the record here today, but it sounds to me that could be, sounds close. And has developed many new bridge technologies, most notably in the development of extradosed bridge structures. Yesterday, Mike Schleich called him the father of extradosed bridges. So we're glad to have him here. He does a lot of experimental research, publishes on a very wide range of topics. In ResearchGates, he lists his field in this order: fields of research, philosophy of science, social and political philosophy, ethics, and civil engineering. Thank you for coming.
Good morning, everybody. And thank you very much, very kind introduction for me. And also it is very honor for me to come here. And thank you very much, Mike, and also the organizer of this conference for giving me a very, very great, fantastic opportunity to be here. Okay, thank you. So we have only 20 minutes. It's a little bit hard. And today's topic, I'm not specialist of the AI, but as a pure engineers, what's going on in the real design field, real construction site, and every time I'm thinking about AI is our enemy or our friends. So I'm a member of FIB, and now our president announced to discuss about the AI and the digitalization as FIB, as a structural concrete. So this is kind of my proposal to the Presidium, and they will discuss in the end of this October. So it's been a long time for my problem of as a bridge designer, and today's the topic is this theme, addition, and leads to the insight and selection. So I show you some books. I'm been reading the kind of books what this idea come from. So this is the first I read in 1968 version, and the Japanese engineer. He's basically Dr. Nakayama. He says, so use your 5 senses, and the memories sometimes connected incidentally, and it needs the quality over quantity. So this is my first book I read. So it was very understandable for me. And 2024, Dr. Iwadate, he's neurosurgery, and he's a professional of the brain. And his book says, and intuition is occurred in a default mode. Default mode is everybody has default mode, but mainly the 80% of energy of the brain is used in the default mode. And also, for example, the running, walking, and the shower, getting a shower, and the brain use wide range of the area of the. And also, sometimes unexpected memories connect with each other, so we cannot control this activity of the brain. And it is important to accumulate, fully understand memories. He's a professional, said, I also understandable for me. And he's the professional of AI, and Professor Kurihara, 2024, he said the title of the book is Cannot Be Done by AI. And he said neither human nor AI can create something from zero. So it happens sometimes, so the experiment in the accident, that occurs something from zero. But usually the new things come from zero, don't come from zero. So distance between the seeds, the born out of curiosity, the more innovative they are. So the distance of the memory is very important. And also he says, and the 5 senses is very important. And AI lacks the ability to create a new value by connecting things. AI is just the data, big data, and even in a professional, I really I'm understandable what he's saying. And this is an English book, and the professor of the Columbia University and the business school, Professor Iyengar, 2023, and her book is very interesting, and innovation is, she said, the new and useful combination of the old ideas. And insight and selection, and she said, she quoted from the very famous genius person book, the insight and selection lead to innovation. Okay, so the Professor Iyengar, she quoted Poincaré's book, Science Method, 1908. So he's a genius, and he's specialized in mathematics, and he wrote a book about science. And he said, and innovation is the process of creating the most useful combination. I agree. And also, invention is insight and selection. This is the Professor Iyengar quote these words. And the most fruitful and selected combination is often a mixture elements from the several different fields. So the distance that Professor Kurihara says, the distance, the longer and longer, the innovation is the more and more creative. So my theme of this presentation is addition with insight and selection. And we make the creative and conceptual design more than 1 + 1 equal 2. So in Professor Iyengar's book, it is very, very interesting for me, the history of the Ford mobile company. So before Ford, in 1901, this is the first application to the new production process. But Henry Ford, he wasn't satisfied this. So he ordered the people of the company to look for another field factories. And one of them, he visited the meat processing plant. At that time, the people, they stay, and also the meat is moving. So I don't know, but Henry Ford has some aha. So maybe some of them you have an experience to aha. So aha experience is very important. And finally, they created the new Ford Model T in 1914. So the productivity is dramatically increasing from 20.5 hours to only 90 minutes per one vehicle. So this is my experience. This is Ponte Vecchio in Corsica Island. And also this viaduct is designed, just a proposal by Jack Matiba. And I will say, Mike, I'm not the father. Matiba is the father of the Exadors. I'm a father of son. Okay, so he built this type of the bridge. At that time, it was very interesting. Not only Exadors, but web is a triangular shape. And unfortunately, the real bridge is only the Garda Bridge in Ponte Vecchio. And I have experience of the corrugated steel whip and the composite steel truss. And each technology has each advantage. And every time I think to make the concrete structure lighter. And I had a aha experience in a business trip from Osaka to Tokyo in the train. So I thought the mechanism is double RN truss. And I changed the truss to the plate, like a butterfly web. So the advantage is the horizontal shear force is not concentrated on the truss, but also the plate is just cut the plate, steel plate to the butterfly shape. So the manufacturer of the steel is very easy. So this is the first concept. The butterfly was a steel. But after that, we had a fiber reinforced concrete. I changed the steel plate to the concrete. Then finally, we built the bridge, the highway bridge in 2013. It took about more than 10 years from the sketch to the real bridge. And now we have 6, this one, and it's under construction, and the span is over 170 meters, Exodus bridge plus, and the butterfly web. So this is my personal thought, the future design, conceptual design. So when I was into the company, it was 1980, just started, just before the started of computer. We use a calculator, but I'm not a generation to use hand-operated calculator and a slide rule or something. But still, we design the bridges by hand. And in 1990, I was in the United States. At that time, the first time to meet the Apple computer. So I was so surprised. And now we have a supercomputer, but everything is based on the calculation by hand. So the by hand is go to the computer. And now we have AI and quantum computer. So we don't know in the future. So I'll explain. This is basic things. We already knew that the bridge is 3-dimensional, but longitudinal, we use a beam, and the transverse, we use a frame. And also, every road is normalized in the earthquakes action and also the live load action. Into the model, and the simplified model, and also the performance is only the 2-dimensional, and based on the calculation by hand. But from now, by using a 3D model, and also all of the action, for example, on the load, simulated for the 100 years, take into account the change of society. For example, Japan, our population is decreasing. And also earthquakes, we can use the very, very heavy model to 20 kilos, and also including 1 million building, and also the soil condition by using a supercomputer. So the simulation of data, of the actions go to the model, and also we have the performance and design data like this from t equals 0 to t equals 100 years. And then we put simulate of the time depends from t equals 0 to t equals 100, and also the deterioration of the structure like this. And finally, after the completion of the structure, it is a digital twin. We have 2 models, and every structure was monitoring and simulated to this digital twin. And also now we can find where the real structure is. This is the design, this is the performance. So this is the position of the real, and also this is the real time. And here is the position, and t equals t1. So now we will find the design and what's happening in the real structure. So finally, almost everything will be done by AI. So in this situation, what should we do? And also, I'm in chair of the Commission 10 of the FIB. Commission 10 is model code. So I think it is necessary to convert the structure of the model code from the present version to another transform version. So everything is changed. So the boundary between the model and the action is going to be the fuzzy. Okay. So this is the nature of conceptual design. So conceptual design, I think knowledge plus experience multiplied by passion. Without passion, everything is zero. And also, the conceptual design has a philosophy. You know that the philo means love, fraternity. And the Sophie is a knowledge. So we love knowledge. But do you think the AI loves knowledge? I don't know. And also, our knowledge is our own weight. My knowledge is different from the Mike's knowledge and everybody's knowledge. But AI learn from the cyberspace. I don't know, but usually they don't have any weight of the knowledge. And also, the human has try and error. This is not on the cyberspace. And also, our memory is a different level in each personality, and we stock our memories by using 5 senses. So this remains for the long time and become seeds that will enter the connected. The connection of the memories we cannot control, but we have to do some effort to train our brain. And also that curiosity, human has a curiosity, and disconnect the something to the another things in our brain. So interesting is very important. So finally, my question for you is: do you think AI has a passion and loves knowledge? So if the AI don't have any philosophy compared with a human. This is a conclusion. The insight on selection is very important, and also everything, invention, it comes from the addition. Our conceptual design is not always focused on the innovation, but every time our conceptual design makes optimized the structure. And also, the computer evolution enables actions side simulation, and the design, construction, and the maintenance can be seamlessly integrated into 3D models. And also, as I said, the boundary from action and also the model getting fuzzier and fuzzier. And also, after the construction, the monitoring 24/7, and the input to the simulator by using an as-built model, and then we get the condition of the structure real time by using the supercomputer. And it is necessary to convert the structure on the model code. The structure is quite different from the present, so we have to start to discuss about this in the FIB. And also, however, since not a human brain information has been learned by AI, so AI, they said in the future, in the near future, the AI finished learning from the cyberspace. But in our brain, so we have many information not in the cyberspace. So for the time being, we will continue to oversee the conceptual design, I believe. And when AI learns information beyond what exists in cyberspace, I mean, do you know the Matrix movie? The brain connected to the AI. So everything go to AI, so it means game over. So again, I'm really understand the Poincaré's say, insight and selection, and also by using 5 senses of the human. And this will remain a human privilege for some time. I don't know, next year, 10 years from now, but we have to we have to collaborate with AI, and we make the conceptual design better and better. Thank you very much for your attention.
I have you can ask your questions in German. I can translate them. Don't be afraid to speak English, though. Donald Trump can do it. Anyone can do it. The last, you say for the time being. I think the developments, I think that's one of the things we talk about a lot. Developments are quite frightening. You also talk about changing the model codes. The question is, what kind of codes are we even going to have, and isn't AI going to change our codes as well?
So this is my personal opinion. Nowadays model code structure is the action and the model and the performance, but the boundary is getting fuzzier and fuzzier. So my opinion, I think the whole structure should be changed to the time or the AI and the supercomputer. So now just start to discuss with the another people in the FYB. Yeah. I don't know, but I'm just getting retired company, but I have a position, part-time position in the university, fortunately. But unfortunately, it is not structure. It is finance. So finance is very important for the engineers. Without finance, our sophisticated technologies go to the real world. So this is my task. But I'm basically a bridge engineer. I love bridge very much. And I will work with AI very, very friendly from now.
Hello, Lubomira Vasileva, a bridge designer from Finland. Very happy to be today here and able to hear you. Very impressed that you bring to us, we should better understand ourselves, of course, in order to comprehend the possibilities of AI. So my question is, how do you see AI? Is it our rival? Is it our companion? How can we utilize it? Is it, do we have to fight against it, like you almost end the session?
Yeah.
Or should we just embrace it's here and take, you know?
Yeah, thank you very much for your question. It is very difficult answer, but I would say only one word. We don't become operator. We become creator. Thank you.